Okay, so number 4, you can see that there are 2 qualitative variables, one of which is multinomial. So our variables are gender and peanut butter preference. And what I've done on this one is I've highlighted, it's right in the question, all I have to do is add an is. That's HR. There is, it's going to look slow on me here, there is a relationship between gender and peanut butter preference. So HO is unrelated, or as I like to say sometimes, no, there isn't. So in the chi-square test, we'll reject HO if chi-square test is greater than some value. Reject HO if chi-square test is greater than some value. Our degrees of freedom on this one, you could blot out one column and one row. You can see it's 2, or you can do number of columns minus 1, number of rows minus 1. Get the product of those. In this case, we have 2 columns minus 1, that's 1. And 3 rows minus 1. And so that's all equal to 2. So we reject HO if chi-square test is greater than 5.99. So I have all my values here, and in the first row I have a total of 200 values. In the next 140, that's just 80 plus 60, and then 60. And then in the first column I have 200. And since I have a 50-50 split across columns, if there were no relationship, then I would expect a 50-50 split in each row. So expected value here of 100, expected value here of 100. Remember, if it's not an even split, take the row total times the column total divided by the overall total. The overall total, of course, is 400, just adding. So if I were trying to get the expected value in this cell, I know it's going to be 30, a 50-50 split, but I could take the row total, which is 60, for this cell. The column total is 200, and divide that by the overall total, which was 400, and that's going to be 30. So the expected value here is 30, as is the expected value here. And in this one, it'll be 70, or half of 140 for each male and female. So if we knew that there were no relationship between male and female, and we had 140 people that liked the smooth, if no relationship, we would expect a 50-50 split, the same split we have of males and females overall. So the chi-square test. I'm trying to find a spot I want to write this. The chi-square test is equal to the sum of, for each cell, the observed minus expected squared divided by expected. So in this cell, remember the observed value is just the values that are given that we saw when we collected the data. So we would have observed minus expected, what we would expect if there were no relationship, squared divided by expected. And that's going to be 4. And 80 minus 100, observed minus expected, squared, divided by expected. That's also equal to 4. Circling these because in the end, I'll go ahead and write here, this is going to be 4 plus 4. My total chi-square is going to be the sum of all of these circled values I have because each cell is observed minus expected over squared. These will always be positive numbers because we're squaring and because we can't have negative values for what we observe or what we expect. Which brings me to another point here. Were I to ask you if the sample size was large enough in this problem, all, remember, in proportions or in qualitative variables, we're comparing to 5. What we would do in this case is look at all the expected values. Look at the expected values, the 100, 100, 70, 70, 30, and 30. All of those are greater than 5. Therefore, our sample size is large enough. So it's the expected values that all have to be greater than 5. That wasn't on this problem, but I thought I should mention that. So observed minus expected squared divided by expected, and that's 1.43. So I'll add that here, 1.43, and here 80 minus 70 squared over 70. That's also 1.43. And then finally observed. Well, not quite finally. We're going to have one more time here. 20 minus, sorry. That was a cough, not a laugh. I'll laugh later, maybe. So that's going to be 3.33. That would have been better if it was a laugh. 3.33. And then 40 minus 30 squared over 30. That's equal to 3.33. So another 3.33. And all of that added together is 17.52. So we said we reject if chi-square test is greater than 5.99. It's 17.82, which is greater than 5.99. So we reject HO, and we conclude that there is a relationship between gender and peanut butter preference. Now you can look further in this and to see that it looks like males like crunchy and females like smooth, and that it looks like more females have no preference. That could affect where you advertise, either to groups that already like or prefer your product, or where you might be able to make inroads into groups that are less likely to like your product.